All right, today we're going to talk about how to add and subtract rational expressions. Now, you know how to add and subtract fractions dealing with numbers, but now we're going to get common denominators that are going to look a little different. How we start this is we want to try to break this down and factor these two denominators to get down to our factors as much as possible. So, for example, I have 2 being divided by x squared minus 4. This is a difference of 2 squares. So because it's a difference of 2 squares, I know that I'm going to have x plus 2 times x minus 2. And again, order doesn't matter if you did x minus 2, x plus 2, that's fine. Plus, over here when I factor, I need 2 numbers that multiply to give me a 4, but at the same time add to give me another 4. So that would be x plus 2 times x plus 2. So 2 times 2 is 4, 2 plus 2 is 4. All right. Now what I need to look at is to take a step back and go, okay, what do these have? Are they perfectly in common? Are they exactly the same? No, one's x plus 2, x minus 2. The other one has an x plus 2, but it has an additional x plus 2. So these are not the same. So what is this one missing? Well, it has the x plus 2, so we're good there, but it's missing another x plus 2. So here I'm missing one x plus 2. What I need to do then is multiply the top and bottom by this x plus 2. Technically, we can multiply by 1 and not mess up the problem. So anything divided by itself is 1, which is why we have to multiply the top and the bottom by that same thing so that we don't mess it up. What we're going to see then is that actually we're going to have to distribute. I'm going to take this 2 because it's being multiplied to the x plus 2. And what that's going to give me is it's going to give me a 2x plus 4. So do you see that? So x plus 2 times this 2, well, when I distribute that, I'm going to get 2x plus 4. So we'll talk about that here in a moment. Now, what is the right fraction missing? Well, it has an x plus 2, and it has a second x plus 2. It's missing this x minus 2. So I'm going to multiply top and bottom by x minus 2. Same thing over here. This x is being multiplied by this stuff, so I need to distribute that out. And so what happens is I have plus x times x is x squared. X times negative 2 is negative 2x. And now finally we have this common denominator. All 3 factors are the same in both. Therefore, the entire denominator is going to be the same. So when I add these together or combine these, I get these factors of x plus 2, and x minus 2. So here is our common denominator. Here is our numerator now after I've added the left plus the right. But finally, we have to combine any like terms we have. And I want to rewrite this so it's in standard form. So x plus 2, x squared is going to be my first term. So I'm good there. This positive 2x and the negative 2x, those cancel out. And finally, I have this positive 4, so plus 4 left over. And then my denominator is x plus 2 times x plus 2 times x minus 2. So this is your answer. This is not factorable, this x squared plus 4. We have a difference of 2 squares, but we don't do sum of 2 squares because you get imaginary numbers. From here, though, there's one more step. So this is the correct answer, but we need to find domain restrictions. Eventually, we're going to learn that those are called wholes and asymptotes, and we'll learn the difference between those. But for right now, we just need to figure out what value of x can I not have because it would be dividing by 0. And I can't divide by 0. So here, how you find that is you take each set of parentheses and set it equal to 0 and solve. Now, we're used to this from factoring, right? So if I have the factor of x plus 2 and I set that equal to 0, what we're saying is that x cannot be equal to a negative 2. Because if I take this and subtract 2 from both sides, I would get a restriction that x cannot be negative 2. Because when x is negative 2 plus 2 is 0, and I cannot divide by 0. Okay, that's one restriction. The second restriction occurs here at x minus 2. If I took that and set it equal to 0 and solved, I'd add 2 to both sides. And so we know that x cannot even equal a positive 2. Now you might wonder, okay, hold on, you have 3 set of parentheses, but you only have 2 restrictions. It's because we have this double root here, this double factor, so it would just negative 2 would occur twice. If you wrote it twice, it wouldn't be wrong, but you don't have to write it twice. All right, let's do this again because I understand fractions, and now we have letters in our fractions. So let's talk about this. This was an addition problem. Subtraction problem is very similar. You just have to be careful with the minus sign. So you have to be careful with that minus sign. Now, over here, we have x plus 1 and then x minus 1. So what is this x plus 1 missing? It's missing this x minus 1. So what I need to do is I need to multiply the top and bottom by an x minus 1. When I do that, 3 times x times negative 1 gives me a 3x minus 3. And this is all over x minus 1, x plus 1. So I just dropped the denominator down. Minus, now I have an x minus 1 in both, but I'm missing this x plus 1. So I need to multiply this denominator by x plus 1. When in doubt, if you have no idea what to do, multiply the opposite fraction by the denominator, and that'll give you a common denominator every time. And it might not be the least common, but it will be a common denominator every time. So I had an x plus 1. The other one was an x minus 1, so I multiplied the fraction by x minus 1. This one's missing that x plus 1, so I multiply by x plus 1. Here when I distribute, what I get is, in the numerator, I get x squared plus x. In the denominator, I'm still with this x minus 1, x plus 1. So notice again, these are the same. They do have a common denominator. Now, when I actually subtract these, be very careful. Make sure you read from left to right when we're subtracting. And so make sure we're also combining any like terms that we have. Notice that we don't have any x squareds, okay? So this is almost like saying 0x squared. Remember how when we were doing synthetic division, we have to put a placeholder in of 0 if we're missing an exponent. So in the same way, I have no x squared here, so think of this as being a 0x squared. Well, what is 0 minus a 1? Well, that's negative 1, right? So this is a negative x squared, a negative 1x squared. Then going to our next term, 3x minus a 1x. Well, 3 minus 1 is 2. So that's a positive 2, so plus 2x. And then finally, again, negative 3 minus, I have no constant, so it's negative 3 minus 0. Well, when you take nothing from something, you still have that something left. So negative 3 minus 0 is negative 3, so minus 3. So there's our numerator. Our denominator, we're just going to leave it in factored form. So we have x minus 1, x plus 1, and we get that because those are in common. And so that is part 1 of the answer, right? This is the answer. This is what we get when we add or subtract, in this case subtract, our two expressions. Now, what we need to do is figure out what are our domain restrictions. What numbers can I not plug in for x? So again, really it's just the opposite sign for this. So instead of x minus 1, that means x cannot be equal to a positive 1 because 1 minus 1 gives me 0, and I cannot have 0. So x cannot be equal to a positive 1, or in my second set of parentheses, it can't be equal to a negative 1. So x can't be a positive 1 or a negative 1. And so this is kind of that second part of our solution. This is our solution. However, in addition to that, our two domain restrictions are that x cannot be equal to 1 or negative 1.